If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. The edge of everything we can see. The realization that our cosmic view has limits came gradually to astronomers over decades of careful observation. In 1929, Edwin Hubble made a startling discovery while studying distant galaxies through his telescope. He found that nearly every galaxy was moving away from us, and the farther away they were, the faster they were retreating. This pattern revealed something remarkable about the universe itself. Scientists soon understood they were seeing the aftermath of an ancient expansion that began 13.8 billion years ago. Light from the most distant objects had been traveling toward Earth for nearly that entire time. But here was the puzzle that changed everything. When that light first started its journey, the objects that produced it were much closer to us than they are today. While the light crawled through space at its fixed speed, the universe kept growing larger around it. The galaxies that sent us their light have since moved much farther away. Today, those same galaxies sit roughly 46.5 billion light-years from Earth, even though their light took only 13.8 billion years to reach us. This creates a boundary that no telescope can ever cross, no matter how powerful we build them. Reading the Afterglow. Scientists expected this ancient light to behave like perfect noise spread evenly across space. Think of static on an old television set. But the CMB maps revealed something far stranger. The radiation showed patterns that should not exist in a simple, endless universe. The most puzzling discovery came from studying the largest patterns in the sky. When scientists looked at how the temperature varied across huge regions, they found something impossible to ignore. The biggest temperature swings were far too weak compared to smaller ones. It was like finding that ocean waves became mysteriously calm only at the largest scales. Even more disturbing was how certain patterns lined up. Two specific wave patterns in the CMB pointed in the same direction through space. They also aligned with the plane of our solar system's orbit around the Sun. The odds of this happening by chance were about the same as winning the lottery while being struck by lightning. One satellite detecting this might be explained away as equipment failure or contamination from our own solar system. But when three separate missions spanning decades all saw the same impossible patterns, scientists faced an uncomfortable truth. Either the universe itself breaks the rules we thought we understood, or we are missing something fundamental about its true shape and structure. The Hall of Mirrors hypothesis. The search for repeating patterns in cosmic background radiation took an unexpected turn in 2024 when the compact collaboration examined data that had been sitting in scientific archives for years. Their team looked at the same Planck satellite measurements that previous researchers had studied, but they asked a different question. Instead of assuming the universe stretched infinitely in all directions, they wondered what would happen if space actually curved back on itself like a cosmic loop. The researchers focused on three specific shapes called three torus variants, each resembling a three-dimensional donut with different twists. The simplest version, labeled E1, showed patterns that would be easy to spot within our visible universe. But the twisted versions E2 and E3 told a different story entirely. When the team ran their calculations, they found these twisted shapes fit perfectly with existing observations. What made their findings remarkable was how they explained those strange cold spots and missing temperature variations that had puzzled scientists for decades. According to their models, a twisted donut universe would naturally suppress certain types of fluctuations in the cosmic background radiation. The very anomalies that seemed like measurement errors might actually be signatures of our universe folding back on itself. If light can travel around the entire universe and return from the opposite direction, we might be seeing the same cosmic structures from multiple angles without realizing it. The cosmological principle under siege. The first warning signs arrived through radio telescopes scanning distant quasars. When astronomers compared their observations to the cosmic microwave background radiation, something was clearly wrong. The Ellis-Baldwin test, designed to check whether the universe looks the same in all directions, kept producing the same troubling result. Radio galaxies and quasars showed a movement pattern 4 to 5 times stronger than what the background radiation predicted. Both signals pointed in the same direction, but the magnitudes didn't match. In 2025, researchers analyzing 1.3 million quasars from the Quaya catalog confirmed this excess velocity signal persisted across the largest sample ever studied. The James Webb Space Telescope delivered an even more startling discovery. When scientists examined spiral galaxies from the early universe, they found a clear bias in how these distant objects rotated. About 66% spun clockwise from Earth's perspective, while only 33% rotated counterclockwise. Statistical analysis showed this pattern had less than a 0.07% chance of occurring randomly. Multiple independent surveys from different telescopes confirmed the same lopsided distribution. The rotation preference formed a clear directional axis pointing near our galaxy's pole. How could the universe show such obvious favoritism toward one direction if space truly has no preferred orientation? The questions that will not close. The most troubling discovery in modern cosmology is not what we cannot see, but what we will never be able to see. Scientists have found that vast regions of space are moving away from us faster than light itself can travel. This means their light will never reach Earth, no matter how long we wait or how powerful our telescopes become. This creates what researchers call a causal horizon, a permanent boundary around our observable universe. Beyond this line, information simply cannot cross over to us. The expansion of space, driven by mysterious dark energy, is actually speeding up. This acceleration seals off distant regions forever, making them as unreachable as if they existed in a separate reality altogether. For scientists trying to determine the universe's true shape, this presents an impossible problem. The cosmic donut, the twisted pretzel, or any other topology might extend far beyond what we can ever observe. How do you map something when most of it is permanently hidden from view? Official records from the Compact collaboration show they are developing new statistical methods to search for indirect clues, faint patterns in the cosmic background radiation that might reveal the universe's hidden geometry. Yet even these efforts face unexpected challenges. Recent measurements from the DESI project found that dark energy behaves slightly differently than predicted, suggesting the universe still holds surprises we have not accounted for. The search continues. Scientists today have more powerful tools watching the sky than ever before in human history. A European space agency launched a satellite called Euclid in 2023 that is now taking pictures of galaxy shapes across huge areas of space. This machine can see how galaxies bend and stretch, which tells us about the overall structure of everything around us. At the same time, a giant instrument in Arizona called DESI is building the most detailed 3D map of the universe anyone has ever made. These new tools are already finding strange things. DESI's 2024 results suggest that dark energy might be changing over time, which nobody expected. Meanwhile, a group called the Compact Collaboration is writing new computer programs to search for circular patterns in the cosmic background radiation that would prove we live in a twisted space. This kind of search has never been tried before because the math was too hard. Even more sensitive instruments are being planned. Future satellites and telescopes on the moon could detect signs of cosmic topology even if the universe's true shape is much bigger than what we can currently see. But the old mysteries remain unsolved. 3 different space missions have found the same weird patterns in the cosmic background radiation, and nobody can explain why certain parts of the sky look colder than they should. How do we make sense of all these clues that don't fit together?